Hello everyone, welcome to ACE Anesthesia. Today's video is a continuation of the previous topic, that is vaporizers part 2. So in this video we'll be discussing about the modern vaporizers, which includes Tech 2, Tech 3, Tech 4, Tech 5, Tech 6 and Tech 7, little bit about Aladdin cassette, Anaconda and Draeger Diva, and then we'll also be discussing about the filling systems and the mounting of the vaporizers. Right. So coming to the tech vaporizers or the tech series itself, all these vaporizers are plenum vaporizers. Okay. They are flow over vaporizers, temperature compensated, agent specific, vaporizers. So all these vaporizers which are present, as we discussed in this previous, they'll be having like a bypass as well as portion of the gas which is going into the vaporizing chamber. So we'll just move from the basic interior mechanism of the vaporizer and we will be seeing what are the specific features of each of these types of vaporizers. So coming to the Tech 2 vaporizer, looks somewhat like this. It has an inlet and it has an outlet. It has a rotatory knob. Okay. And this one will be the filling port. This is somewhat like a drainage port. And this will be the vision glass. Okay. So the Tech 2 vaporizers which were present, so this is one of the oldest of all the tech vaporizers which were temperature compensated ones. Okay, so they have that bimetallic strip which we discussed that consists of brass and invar that will be helping regulating the output and help in temperature compensation, and hence it prevents the falling of this vapor output with time. Right. So in these Tech 2 vaporizers, since it was very older form, most of them were containing or they were used for halothane. So this Tech 2 vaporizer had one defect, that disadvantage is that of pressurizing effect. So what is pressurizing effect? So this effect is that whenever there is an increase in the fresh gas flow, the vapor output concentration will reduce. Why? Because each of the liquid agent is having a specific saturated vapor pressure at a particular temperature and pressure. Right? So whenever you increase the fresh gas flow, there is dilution of the vapors by the carrier gases. So this dilution causes decrease in the vapor output, and this is called as pressurizing effect. So to overcome this disadvantage came the next model. This is Tech 2, right? Next model was Tech 3 vaporizers. So what did they incorporate in Tech 3 vaporizers? So Tech 3 vaporizers, whenever we start describing, this is also a plenum, flow over with wicks. It has variable bypass. It is agent specific and it is temperature compensated. So these four features always come in all the tech vaporizers. Okay. So what thing they improvised from the Tech 2 to Tech 3 vaporizer is that they made the vaporizing chamber smaller. They increased the route to the vaporizing chamber so that all these pressurizing effects will not come into the picture. Right. So Tech 3 vaporizer was available for halothane, isoflurane, enflurane and sevoflurane. Okay. So this is the Tech 3 vaporizer. Coming to the next model of this, that is the Tech 4 vaporizers. Tech 4 vaporizer on a gross scale looks somewhat like this. It contains a rotating scale. Okay. And this contains one red color button within which it is called as the release button. So whenever we are turning on the rotating knob which is present, we have to press the releasing button in order to switch it from the off position to the on position. Okay. Another feature of Tech 4 is the interlock systems. Okay, that will prevent the use of multiple agents at the same time. We'll be discussing this in regarding the mounting systems. Okay, so this is the interlock system which will be there in the Tech 4 vaporizer. It contains a release button. The dial is also present with finer scales. Okay, and it actually can carry up to 0.25 to 12 liters of flows. So this is also temperature compensated plenum variable bypass, and it is also agent specific. It has a filling port which is present, and whenever it is in off position, all the gases will go through the bypass chamber, but when it is in on position, part of it goes through the vaporizing chamber and part of it goes through the bypass chamber. One important upgrade from Tech 3 is the presence of, like within inside this, the vaporizer contains wicks with helical system, which will increase the surface area for the vaporizing liquid. So it helps in formation of more vapors. Okay, and this wicks and baffles also help in preventing, that is, spilling of this liquid agent when we tilt the vaporizer. So usually from Tech 4 onwards, it can be tilted up to 180 degree without causing like leaking of the vaporizing agent. So next we are coming to Tech 5, Tech 7 and the later models which are of the Tech vaporizers that are present. So more or less they have similar features. Certain things which are an upgrade to this, so including all the basic features like it is a plenum, it is a flow over, temperature compensated, agent specific. Kindly note I left out one more point, that is it is variable bypass. Okay, so this was one of the point which also applies to all the Tech vaporizers. So variable bypass will also come. So in Tech 5 and Tech 7, an improvement over the Tech 4 which we can see that it has finer scales, so that we are able to provide, that is, lesser values of the vaporizing agent also. So from 0 to 1 you have more graduations that are present, so that you can give lesser values also. Number 2, they have new key filling systems or the funnel filling systems which are present. Okay, so this is an upgradation from the older models which are there. Another thing is that they can be tilted up to 180 degree without causing the leaking of the vaporizing agent. Right. So another thing is that all this will be also having those helical baffles which are made up of Teflon, that is kept open with stainless steel wicks. So this basically prevents the pressurizing effect that is caused in the vaporizers. So next we come to the Tech 6 vaporizer. So this is a special type of vaporizer which is designed for the specific agent, that is desflurane. Okay. So Tech 6 is also a plenum type of vaporizer. It's a variable bypass. It is agent specific, that is, it is only for desflurane it has been prepared, and it is temperature compensated by supplied heat. So why is it a special type of vaporizer? The features or its special features lies in the agent itself. As we all know, desflurane is having a saturated vapor pressure of 669, okay, at 1 atmospheric pressure. So if it is having so high of saturated vapor pressure, what is our normal atmospheric pressure? Our normal atmospheric or the barometric pressure is 760. So almost it's very close to that of atmospheric pressure. right? So when the saturated vapor pressure becomes very close to this, the agent starts boiling. So what first we'll come to see what is the volume percentage we will achieve by using this saturated vapor pressure. That is 669 divided by 760 into 100, which comes to approximately 87%. So when the saturated vapor pressure is so close to that of atmospheric pressure, desflurane is actually producing about 87 percentage of volume concentration. But what we use in our everyday practice is about 6%. So to make this 87% into 6% of vapor pressure, you require very high amount of gas flows, which is not possible by our machines. So in order to overcome this, this Tech 6 vaporizer increases the pressure of the vaporizer itself to 2 atmospheric pressure, so that we are able to deliver the desflurane at a clinically important value of volume percentage. So it has very high minimum alveolar concentration, and also it is having low boiling point. Okay. So number one, which is having very high saturated vapor pressure, number two having a very high MAC, and number three having low boiling point. So these are the three features which makes the desflurane a special volatile agent, and hence it requires a specialized vaporizer, that is our Tech 6 vaporizer, right? So Tech 6 vaporizer, usually when we see within the anesthesia machine, it will be at the that is the farthermost end. Why? Because it also contains an electrical cord which has to be charged. That is required for the supplied heat which the vaporizer is receiving. The usual Tech 6 vaporizer that is present, it has 0 to 18% as the dial. Okay, it has a release button. Okay, that will be activated after 12%. You will have to press the release button in order to increase the concentration beyond 12%. Okay, and it is very specific only for the desflurane agent, and it also contains a cord which you will be seeing several light indicators indicating whether it is an operational state or not before turning on the vaporizer. So whenever you switch on the desflurane vaporizer, it takes about 5 to 10 minutes for the vaporizer to heat by the externally supplied electrical heat, and hence after that it will come into an operational mode, after which only you will be able to rotate the rotating valve or the dial of the vaporizer, right? So after coming to this diagram which I have drawn, it's from Miller's. It basically tells about how the Tech 6 vaporizer actually works inside, right? So this flow which is present, this is the inflow of the fresh gas flow which is coming. Okay, so this is the inlet of the fresh gas flow. It flows and it encounters what is called as the resistance 1 or the R1. So this R1 it encounters, and there is a pressure that will be transmitted to the differential pressure transducer. Okay, so this differential pressure transducer will send the information to CE, that is computer electronics. Okay, so fresh gas flow will flow, it will encounter a resistance, and the information will go to a differential pressure transducer, and this R1 or the resistance information goes to the computer electronics. Okay, so this is one end. The other end will be the vaporizer end. So this is the desfluorine vaporizer with a reservoir containing the liquid agent. Here what happens, there is a sump. So this is sump shut off valve. Okay, so there is a sump shut off valve. So what is a function of this? So even though there is a fresh gas flow, the desfluorine just can't start giving off the vapors. Basically what happens is that this sump shut off valve ensures that the desfluorine vaporizer reaches 39 degree Celsius. Okay, once the desfluorine vaporizer gets heated only, the sump shut off valve opens to allow the vapors to go inside the circuit, right? So this computed electronics gives the information about the resistance or the information about the fresh gas flow. So once information goes to the sump shut off valve, it also gives an information to this red thing which I have marked as the pressure reducing valve. Okay. So what happens once the valve of the vaporizer opens, it encounters a second resistance which is called as R2. Okay, this is called as R2. So what happens, this information of R2 also goes to the computer electronics. So the main work of this is to ensure that R1 becomes equal to R2. That is, pressure exerted by the fresh gas flow should be equal to whatever pressure is there within the vaporizer side. So when this happens, this is called as the working pressure. So this is called as the working pressure of the vaporizer. So once when this occurs, if the pressure in that side is very high, then the pressure reducing valve will accordingly manage it. Okay, so this is called as the working pressure, and hence there will be an outlet where the output vapor concentration goes. Okay, so in a way the Tech 6 vaporizer acts like an injection type of vaporizer. Okay, next we come to Aladdin cassette. Aladdin cassette was manufactured by the GE Healthcare. So this is also a plenum. It's a variable bypass. Okay, agent specific, and it is electronically thermocompensated. Okay, so Aladdin cassette is having all these basic features. So coming to the how it looks, so I have drawn the gross diagram. From the front, Aladdin cassette looks somewhat like this. It has 4 copper temperature sensors. Okay, and this is a release button with a handle lock that is present. Okay, right, this is the filling port and this is the vision glass with the level indicator. Usually the agent name may also be written and it is color coded, right? From the behind, the Aladdin cassette is having 2 ports which may be an inlet and outlet port for the gases, and also a temperature sensor that may be present. Okay, so Aladdin cassette is one of the advanced cassettes for the delivery of the gases. From internally it looks somewhat like this. So this is the bypass chamber for the gases to flow. This is the vaporizing chamber. Okay, so this is the check valves which are present at the inlet of the vaporizing chamber. There is also a pressure relief valve. Okay, so that is also pressure present. So when the gases enter through this and this there is a agent control. There is also a agent control knob, right? So all these things, that is this pressure, there is a check valves, there is a pressure relief valve, there is an agent control valve, all this information goes to a CPU, right? Once it goes inside the vaporizing chamber, there is also a pressure regulator and there is also a temperature regulator. Both of them are present within this Aladdin cassette, right? They also give some information to the CPU, and there is the outlet through which the vaporizing liquid goes out and goes to the output, right? So there is also a what you call as a cassette outflow sensor, right? So this will also give some information to the CPU. So this is how Aladdin cassette basically works. So there is a bypass, there is a vaporizing chamber, it enters, it is having a check valve, it has a pressure relief valve, and there is also an agent control knob that will give information to the CPU, right? The fresh gas flow enters, takes up the vapors, there is a pressure control and a temperature control sensor, and there is an output. There's also a cassette outflow center. So all this are like almost electronically controlled type of a vaporizer it is. So whenever we attach this Aladdin cassette to the machine directly identifies by the magnetic sensors, right? It will identify the fresh gas flow, it will identify the agent concentration which we are giving on its own. And also some of the safety features of this is that it will help in directly identifying the agent, okay, number one. Number two is that whenever the vapor level becomes less than 10%, it gives an alarm on its own, okay, right? And also all this Aladdin cassettes and all always have to be filled in a horizontal position, that is you can't tilt and then fill it, and always off the vaporizer before filling the Aladdin vaporizer, right? And one more thing with Aladdin vaporizer is that especially for desflurane, right? Desflurane vaporizer is electronically heated like even like the sevoflurane or any other agent which the Aladdin cassette comes in, right? But for desflurane, there is a feature that if it is less than 22.8 degrees Celsius, it will be usually like a variable bypass form only, it will be there. But if it is more than 22.8, the Aladdin cassette acts like an injection type, okay. Most of these Aladdin cassettes also have a fan at the rear end in order to maintain the temperature of the cassette by 18 to 20 degrees Celsius. So next we'll be seeing about Draeger Diva. The Draeger Diva, it was manufactured by Draeger. It is a plenum type, okay, measured flow. It's an injection type of a vaporizer and it is agent specific, right? So in Draeger Diva, the Diva is direct injection of volatile anesthetics, right? So this is the full form of Diva. So whatever is this Draeger Diva is present, it is having like a storage tank and a pump tank, and it has a separate module for the Draeger Diva itself. That is, it has a separate gas supply that will be receiving by the Draeger Diva vaporizer. So whenever we are setting up this Draeger Diva, we have to mention the fresh gas flow. We set up the agent concentration or the end tidal concentration of the agent has to be mentioned, and automatically what happens that within this chamber itself, the vapors of the volatile anesthetic agent that is present is injected in order to ensure the set and tidal concentration of the particular agent. Right. So next we will come to anaconda. So this type of a vaporizer is used in the ICU settings. Right. It is a closed loop delivery system. So what happens that the patient is connected to a gas monitor, okay, a ventilator and a syringe pump. Okay, so this anaconda is present between the catheter mount and the Y piece of the circuit. So here is the Y piece. The components of the anaconda contains carbon fibers. Okay, they'll be also containing the bacterial filters, and this is the syringe pump that is delivering the liquid anesthetic agent. So it passes through this, the liquid anesthetic agent is supplied, 90% of this agent is returning back through the patient's exhaled breaths, which then condense back and they are re-inspired during the next inspiration. So coming to the last portion of this video, the filling systems, we have the screw filling systems, we have the keyed filling systems, we have the easy filling and the safety filling systems. Right, for the screw filling systems, basically the filling port is having a screw which is opened up and it is filled, which usually contains the bottle. The key filling system which is present, it contains the bottle with an adapter which actually fits into the vaporizer opening and it is lifted and filled. Okay, in easy filling system, the bottle cap itself contains like the ridges and also collars that will be fitting over into the filling port which is present in the vaporizer. Like safety filling systems which are present, that is in Tech 6. So usually the bottle with the ridges are there. It contains a plunger which is directly pushed into the filling port of the Tech 6 vaporizer. So once it is withdrawn, it automatically closes. This is the safety filling systems. So one important safety mechanism with vaporizer mounting system is select a tech mechanism. So this is a mechanism which will basically prevent more than 2 vaporizers. Okay, more than 2 vaporizers to be opened simultaneously. Okay. So what happens that whenever we are mounting a vaporizer, we mount it in a where the lock is closed. Okay, and it is in T or the transport mode in a Draeger type of vaporizer. Right. So whenever we fit into this vaporizer onto this mount, there are 2 opening valves which are present on which we mount it onto the vaporizer. So this will be in the machine and the vaporizer is fitted onto this vaporizer mount. Okay. So once we fit this vaporizer into this mount, okay, and we open the dial, the valve which was closing this port comes down and then it allows the gases to flow into this vaporizer. In select a tech mechanism, whenever you open, this is one vaporizer A, there is another vaporizer B. So whenever you open this vaporizer, it actually extends a rod on either side, right? And it prevents the B vaporizer to be opened, right? This is called as select a tech mechanism, which is one of the safety features of a vaporizer. We have come towards the end of this video. We have discussed about modern vaporizers. I've tried to enlist the brief features of all the vaporizers. I hope I could make things simpler for you all. If you have any new topics to be discussed, please let me know in the comment section below. Keep supporting. Thank you.